अस्सलाम वालेकुम। ये आपकी क्लास बाकी लोग किधर हैं? अली, हमजा। Ali Hassan, are you there? Ali, are you listening me? Please ask your class to join. We are getting late.
If that's
So 12 minutes gone. As usual, only 3 students in the class. It's very bad. So let's summarize what we studied in the last lecture. Ali, can you tell what did we study in the last lecture, and to what extent we had gone? Ali, Fahim. Yes, wave energy generation, but what did we study? How waves are produced? What is the source of production of waves? Yes, wind energy is the source. Yes, it's right. Can you explain how wind produces waves? Basically, global winds are involved, right? I had told you that winds can be regional and winds can be global. Global winds are those which work around the globe, right? Because of the phenomena, because of the sunlight and motion of the earth, right? There is a region at 30 to 60 degree where we get the highest level of winds in northern hemisphere and in southern hemisphere, and that is the region where most of the winds blow. And in that region, most of the time there will be winds, right? So these winds cause the waves in the ocean, right? And this is the global waves, right? But for regional global winds, and there are regional winds as well, because of the terrain, the how the earth portion is made. Is it water? Is it land? Is it desert? Is it plants or what? Right? And what is in the surrounding? I mean, you can say geographic conditions, right? And are there mountains, or is it a plain land? Is it a seashore area, or what else, right? So these different factors cause winds to blow. We will study in detail about winds in wind energy, right? So these are regional winds, okay? So there are global winds and regional winds. Waves are produced by winds, whatever the cause of the wind production is, right? But mostly the waves of our interest are generated by global winds, which are found in the regions of westerlies, uh, either in northern hemisphere or southern hemisphere. Now, because we require waves more than 3 meter high with amplitude more than 3 meter high, that means amplitude is 9 meter. It may be 9 meter to 3 to 7 meters. Normally they go 9 feet to 21 feet, right? Is the size of waves. Now, my question is how wind produces these waves. We had discussed it in detail in the last lecture. Hamza. Hamza Farooq, are you there? Yes, it winds transfer energy to the waves. Yes, true. But how? That is the question that might be asked in the exams. I don't know about the possibility of physical exams, or exams will be conducted on slate, but that is an important question. So nobody can explain this question. Next question is,
सर जब वेव्स स्ट्राइक करती हैं वेव्स के वाटर के साथ तो वो वेव्स जनरेट कर देती है।
जब विंड वाटर की जो विंड वाटर के सरफेस के साथ ब्लो कर रही है, उसके करीब ब्लो कर रही है, उसके विंड के मॉलिक्यूल्स वाटर के मॉलिक्यूल्स को भी मूव करवाने की कोशिश करते हैं। डेफिनेटली वो भी फ्लूइड है, ठीक है। तो ये विंड के मॉलिक्यूल्स वाटर के मॉलिक्यूल्स को साथ इस तरह से उसको मूव करवाने की कोशिश करेंगे और वो मूव कर जाएंगे। और इसी तरह ऊपर वाली लेयर जो सी है वाटर के मॉलिक्यूल्स की, वो मूव करेगी तो उसे नीचे वाली भी मूव करना शुरू कर देगी उससे कम स्पीड पे। ये इसी तरह से ग्राफ जो सा इधर जाना है, इनकी
जैसे
मूवमेंट।
ऐसे ही और स्पीड रेट रिड्यूस होता जाएगा,
क्या
स्पीड रेट रिड्यूस होता जाएगा आहिस्ता आहिस्ता।
क्या रिड्यूस होता जाएगा?
और सर मैं कह रहा हूँ एकदम स्पीड रेट रिड्यूस होता जाएगा, फर्स्ट लेयर की ज्यादा होगी, सेकंड लेयर की उससे कम, थर्ड लेयर की उससे कम, और
हाँ,
अंटिल वो जैसे जैसे डेप्थ होती जाएगी वो स्पीड उसकी कम होती जाएगी।
उसका एम्पलीट्यूड कम होता जाएगा, ठीक है। वेव का
यस
एम्पलीट्यूड
सर।
वो कम
तो
होता
सर
जाएगा
एक दफा
यानी
मतलब
यहाँ पे अगर ये इस तरह से बन रही है तो इस डेप्थ के ऊपर ये इस तरह से बनेगी, ठीक है, और इस तरह से, और उससे नीचे वाली उससे कम, तो अल्टीमेट ये फ्लैट हो जाएगी, ठीक है। और इसमें होता क्या है कि पार्टिकल जो है ये मूव नहीं कर रहा, पार्टिकल सर्कल में मोशन कर रहा है। जितना ज्यादा एम्पलीट्यूड उतना बड़ा साइकिल का रेडियस है, ठीक है, क्योंकि ये पार्टिकल इस तरह से मूव कर रहा है, ठीक है। ये इसकी किधर लिखा हुआ था, ये wind attempts to stretch the surface of the sea by rubbing against the surface of water. This causes water molecules on the surface to move in the same direction as in the wind. The water molecules collide with each other and start moving forward. It's just basic friction, ठीक है। So ये अब वाटर मॉलिक्यूल जो से हैं ये सर्कुलर मोशन में गए हैं, इस तरह से, ठीक है। जितना बड़ा वेव का एम्पलीट्यूड होगा, जितनी बड़ी वेव होगी उतना ज्यादा उसका एम्पलीट्यूड होगा। एम्पलीट्यूड मींस दिस डिस्टेंस, ये नॉर्मल लेवल है।
नारा वामदा
अच्छा जी, सॉरी, आई थिंक मेरा ख्याल है मेरे इंटरनेट का कनेक्शन जो है वो वीक है और सिग्नल जो है और वो इस वजह से ये डाउन हो गया। So we were discussing, this is the amplitude from the normal surface of the sea, the height, this height to the maximum point, maximum height. This is the amplitude of the wave, right? So wave height is from this point to this point, okay? So for higher amplitude, circular motion will be greater. I can't do anything. My connection is that means not good. Internet signals are not good at the moment. So try to listen to me, and when it is clear you can tell me. If you want, I can we can discuss it again, okay? If you cannot understand something, we can discuss it again. So this is the kind of pattern found in the uh, water particles, right? I had shown you the animation for this. this is how water molecules move, okay, with wave. So water molecule is in circular motion, and they don't change their uh, place. Actually, they do not get migrate, they are there, right, but going through the circular pattern. And uh, the with the depth, the circular motion, the radius of the circular motion gets reduced with 1 over exponential 1 over e, with the which is proportional to 1 over e, right, the growth level. So most of the waves which are of our interest and which can harness good energy have wavelength of 100 meters, amplitude of 3 meter, at depth of seabed greater than 30 meters, right? So wavelength of 100 meters, right, and amplitude of 3 meter. Amplitude means 9 feet high, almost 9 feet high wave, right? So at the depth of the sea greater than 30 meter, because the wave production is dependent upon the speed of the wave of the wind, the duration and the fetch, right? क्योंकि विंड कंटिन्यूसली नहीं चल रही होती, ठीक है, हवा का एक झोंका आता है फिर रुक जाती है, फिर चलती है फिर रुक जाती है। जितनी देर तक हवा चलेगी उतनी वो विंड को उतनी देर तक वो प्रोड्यूस करवा सकती है, पानी के मॉलिक्यूल्स को इस तरह से लेके उठा के साथ चल सकती है। जितना दूर तक लेके जाएगी उतनी बड़ी विंड प्रोड्यूस होगी, उतनी बड़ी वेव प्रोड्यूस होगी, ठीक है। जितनी तेज चल रही है उसके हिसाब से वेव प्रोड्यूस होगी, ठीक है। सो wind the wave is dependent upon the speed of wind, its duration and fetch, three things, okay. And another thing other than wind is the depth of the sea level and topography. Depth means how deep the sea is from the surface, right? And the other thing is what kind of surface on the sea level is, right? If this is the sea level, right, what kind of surface is this? Is it something like this, or is it plain? Are there any rocks or mountainous at the seabed, or it is simply a plain sea, right? In plain sea, it is helpful. It will help in developing the waves. But if there are humps, right, like this, then they will definitely not let the particles move ahead, right? So that will become a restriction in the path of wave, right? So waves will not get developed in that region where there are there the topography is not plain but rough and sort of rocky or mountainous. So so wave depends upon the wind, depth of sea and the surface of the sea, right, topography of the sea. For that, for defining the surface, we use the word topography, right? So the topography, depth of the sea, topography of the sea, wind speed, wind duration, and wind the fetch, the distance with which wave have moved. If I ask you the question, what factors are required for developing a wave, you have to write only these 5 points and you'll get the marks, okay. Don't need any long descriptions, just few words. Now wavelength of our for the waves of our interest are 100 meters, amplitude 3 meters and depth more than 30 meters. If that is the condition, then we have waves of our interest which can produce with which we can produce good energy, right? and most of the energy is produced because of this kind of motion, this kind of motion of water at that place. Okay, so in deep waters, the circular path particles have an amplitude that decreases exponentially with the depth and becomes negligible for d is greater than lambda by 2. That means for 100-meter wavelength,
Mhm.
at the depth of about 50 meters, there will be no wave at that depth, right? So and that will be just a plain layer of water. In shallower water, the motion becomes elliptical and water movement occurs against the sea bottom, producing energy dissipation. So when the sea becomes shallow, right, or the depth reduces, the energy is dissipated, right? So that's why you can see on the seashores or the beach areas which have a very slow slope, right? In the sea, waves come here and then die, right? And they get finished and they dissipate all their energy. So at the depth of lambda by 2 pi, at the depth of lambda by 2 pi below the mean surface position, amplitude is reduced to 1 over E, where E is the mathematical expression, which is the base of natural logarithm. Its value is 2.7182, right? At the depth of lambda by 2, motion is negligible, being less than 5% of the surface motion, right? So, so another important factor is that we get the wave energy, we produce the wave energy at the surface of the sea, right? If we compare with the tidal energy, in tides, the energy producing devices are immersed in water at certain depths, right? But in waves, all the devices work over the surface of the water, right? And they have to take the advantage of this kind of motion. So that is another difference between wave energy and the um, the tidal energy. Yes, but one technology is there, which is uh, caption, right, in which we collect the water in some reservoir and let it go through um, a wind turbine, or a small turbine, water turbine, right? That is the only technology that uses submerged device. Otherwise, most of the devices are work on the surface, right? And they have to take advantage of this kind of linear motion. So just give me 2 minutes. So Let's resume again. Um, this is what kind of forces act on the molecule when it is in circular motion. Basically, there are only two significant forces. All the other forces, which are friction, surface tension, and inertial force, are very small. Friction, surface tension, and inertial forces are very small as compared to centrifugal force and force of gravity acting on the particle. So what is centrifugal force? Mv square upon r, right? So for when there is circular motion, we can say m r omega r square omega square over r. So it becomes mr omega square. Okay, this expression, and this is the force of gravity acting on it. So at any point, the resultant force is the net force based on the addition of these two vectors, two force vectors, right? So since particle is moving like uh, this, right? This is the motion. So it is a point when particle is going like this, right? As my mouse pointer rotates. Okay, so at this point, when it reaches here from bottom point, and it is rising and it is at the mean position, the no sorry uh, it is coming back. Okay, it is this position, right? It is from top, it is coming from top to bottom. Okay, in this manner, the particle is coming from top to bottom. So at that point, here is the this is the centrifugal force, right? And this is the weight. So resultant force is like this. So when we see a particle at the topmost point, the centrifugal force is pointing upward, right? So centrifugal force is pointing upward when it is going, it is at the topmost point, and weight is moving downward. So net force is like this. Okay. So when then it reaches at this point, which is similar to this, right? So centrifugal force is moving away from the circle. It is pointed outward from the center, and weight is acting down. So resultant force is like this. At the bottom, at the bottom point, wave is centrifugal force is also acting downward, and weight is also acting downward. Both the forces are acting downwards. So net force is resultant of these two vectors. And when it is rising and reaches the mean position, centrifugal force is away from the circle, center of the circle, which is here. So it is pointed in this direction, and weight is acting in this direction. Resultant force is like this, right? So this is how, so you can calculate at any point, any instant, the resultant force, right? So this is how the uh, forces act on the circle, right? So radius of the circle is equal to the amplitude of the wave, right? And h is the distance from trough to crest, this distance. So that is equal to 2a, amplitude multiplied by 2. Angular velocity of the water particle is given in radian per second. So this is how the forces act on the water. Uh, I think this much is enough for you, right? We don't want to go in the depth. And for calculation of the power in the wave, the formula is power is equal to rho g square over 64 pi h square te. H square is height of wave, significant height, right? It is the distance between trough and crest, right? And t is time period. So the more the amplitude is, the more the height is, and if height is made twice, the amplitude is 4 times. So power is 4 times, right? So this factor may reduce to something like 0.5, right? This one. So 0.5 multiplied by h square Te is the power for wave energy. Now, the different devices for capturing the wave energy are water capture system. That is the only system in which submerged device is used. In this, a wave, a high wave we make a small reservoir. A high wave will jump this wall and enter into this reservoir. So its level will rise, right? So when and we store that water, and then we let the water get out through this passage. There is a turbine housing, and only path for the water to go out is through this passage, and in this we can run the turbine and let the water get out deep, and this requires deep water seashore. Okay, uh, just like maybe we can say water, but we do want some beach like area, right? We want to go into the deep sea where and some and the earth, I mean, if if you go to a place where you are sitting on the edge of the earth, of the land, and sea is deep down, right? At those places you can make this setup. Then oscillating water column. This is a wave, and this is a passage, closed passage, in which water level rises in, and since water level rise and falls in this portion, air present in this portion will, when the water is rising, air will go out from this passage. Okay, and when water level falls, air will come into this portion. So what we can do is we can let the air go out or into this portion in this space through a small passage, right? And that passage, in that passage we can run a pneumatic turbine. That pneumatic turbine, because of the flow of air into or out of this space, will let the turbine run, and that turbine is connected with the generator, uh, and energy will be produced. So this is one of the LIMPET, land installed marine powered energy transformer. So in reality it will look something like this. So one of them is designed in Scotland. Wave technology is relatively younger or newer as compared to solar and wind energy. Solar and wind energy, a lot of investment is done on these technologies, right? But and they are fairly developed. Wave energy technology is not that developed. One of the reason is that wave is not available to all the developed countries, all the countries. Well, it is available in USA, Canada, United Kingdom, Scotland, Ireland, and China. Japan, and these areas, right? But it is not available to most of the countries with that potential, right? So the other thing is that it requires some good materials as well, right? The advantages of wave energy are this is continuous. Once wave is produced, it has energy, right, which will not dissipate very easily as is done in wind, right? So it is available day and night. As compared to solar energy is only available on sunny days in the daytime, not at night.